Today's conic section focus is on the ellipse. The ellipse is what you get when you slice your parabola with a plane, your cone with a plane, but a slanted plane. So it's not a hyperbola, it's not two straight lines or one straight line, it's not a point, it's not a circle, but it's this, a ellipse. The formal definition of an ellipse, it's the set of all points that are equidistant to two focal points. So it has a major radius and a minor radius, and they add up to the same length. We are going to be finding the center, the foci, the vertices, and the endpoints of the minor axis of an ellipse. And we're going to use completing the square to rewrite equations. This formula is on your note sheet, but I want to point out a couple of things. The first thing is that you can tell whether your ellipse is going to be short and fat or long and skinny by just deciding which one of these two numbers is bigger. If the bigger number is under the x coordinate, then your parabola is going to be longer in the x direction. Your major axis will be parallel to the x-axis. And if your larger number is under the y-coordinate, then your major axis will be parallel to the y-axis. So that would be a long, skinny ellipse. The other thing I want to point out is that ellipses are always equal to 1. And so if you find yourself with an equation that looks like an ellipse equation but isn't quite, then that just means you have to divide to make that a 1. And when you divide both sides by whatever number that is, that just helps you figure out what A and B are. The way you find the focus is the only part that involves real math. This part is going to involve the Pythagorean theorem, because if I take this, imagine this focal distance moving up here, I get a right triangle, and the hypotenuse of that right triangle is going to be A. Or I guess a nicer way to draw that triangle, now that I think about it, a nicer way to draw that triangle would be to draw it like this. I'm going to draw this, and I have A is going to be the hypotenuse of that triangle. Anyway, so I'm looking at this first example, and I'm noticing that my larger number is underneath the y-coordinate. That means my major axis is going to be parallel to the y-axis. So this is going to be a long, skinny type of ellipse. Okay. Now, if I want to find the center, the way I find the center is by using H and K. There are subtraction signs in my formula, so since both of these look like they're negative, the center is actually at +3, +2. So if I want to plot that, I'm going to have a point at 3, 2, and that point is going to be halfway in between my two foci. The vertices are going to be at the ends of the major axis, which for us is parallel to the y-axis. And so the two vertices are going to have the same x-coordinate as the center, because they're going to be on this line here. And so they're both going to have an x-coordinate of 3. And then the major radius is going to be the square root of 16, or 4. So this is the center, and I'm going to have a vertex which is 4 lower than that center. So this is going to be one vertex, and then I'm also going to have a vertex that is 4 higher than the center. So this would be the other vertex. The way I do that mathematically is I would say, well, one of my y coordinates is going to be 2 plus 4, and the other y coordinate is going to be 2 minus 4. So my two vertices are going to be at 3 comma 6 and 3 comma negative 2. My minor axis is going to have, my minor radius is going to be the square root of 4, or 2. So that means that from my center, I'm going to have a endpoint here and an endpoint here. They have the same y coordinate as the center, so they're going to both have a y coordinate of 2, and I'm going to add 2 to the x coordinate, 3 plus 2, and I'm also going to subtract 2 from the x coordinate, so 3 minus 2. So my co-vertices, or the ends of my minor axis, are going to be 5 comma 2 and 1 comma 2. The foci, that's the one where we have to do a little bit of math. We do know that the foci are going to be on the major axis, so that means that they're going to have an x-coordinate of 3, and the y-coordinate is going to be the center plus c and the center minus c, or the y-coordinate of the center minus plus and minus c. So in order to figure out c, I'm going to remember that that's going to be a squared minus b squared is going to give us c squared. So 16, which is a squared, minus 4, which is b squared, is 12. So that means that c squared is 12, or c is the square root of 12. Or an even nicer way to write the square root of 12, remembering that 12 is 4 times 3, and we can take the square root of 4, but we can't take the square root of 3, is that this would be 2 root 3. So that means that our focus is at 3, 2 plus 2 root 3, and then 3 comma 2 minus 2 root 3. And that's how we find the major, the center, the vertices, the co-vertices, and the foci of a parabola. An ellipse. What our ellipse looks like is it goes through our vertices and our co-vertices, and it makes that kind of stretched out circle shape. In class, we talked about how you would write an equation if you have an ellipse, and you can find the center and you can find the major radius and the minor radius. So here I can figure out that the major radius is going to be the distance from -4 to 0, or 4. And the minor radius is going to be the distance from 5 to 2, or 3. So that means I need my center. The center x coordinate is negative, so that makes it x plus 4 squared. And then I'm going to use over 4 squared plus, and then my y coordinate of my radius, my center is positive, so I'm going to make it y minus 2, and that would be over 3 squared. And with an ellipse, it's always equal to 1. So this would be x plus 4 squared over 16 plus y minus 2 squared over 9, and that's equal to 1. So that's how I'd write an equation for an ellipse if I have a graph of an ellipse. Sometimes in order to go through the process of finding our center and our vertices, and focus, we're going to have to rearrange our equation using completing the square. So again, the way we do that is we're going to gather our x's together. So 4x squared minus 32x. We're going to gather our y's together. I'm going to leave some space here because I know I'm going to be completing a square. y squared plus 16y, leave some space, equals, I'm going to subtract 124 from both sides, negative 124. Now before I complete the square on the x's, I'm going to factor a 4 out so that I am just completing the square inside of these parentheses. But I can leave the y's alone because that y squared already has a coefficient of 1. For the square for the x's, I'm going to use x squared in this corner. And then I need my two diagonals to add up to negative 8x, so that's going to be negative 4x. And that means that my parabola, my my dimension is x minus 4 squared, so this would be a 16. So that means I'm adding 16. But I really added 4 times 16 because I had that 4 factored out already. So I'm really adding 64. And then on the other side, I don't have to worry about distributing out anything. So this would be y squared, and the 16 has to be evenly distributed, so it's going to be 8y and 8y. So this would be y and 8. So this corner, the missing piece is a 64. That means I'm adding 64 again. So my new equation is going to be 4, and then x minus 4 squared, because those are my dimensions, plus y plus 8 squared, because those are my dimensions. And then I'm going to combine these together. I have 128 minus 124, and that would be positive 4. Now remember, with an ellipse, you always want your ellipse to be equal to 1. So that means that we're going to divide both sides of this equation by 4 so that we can be equal to 1. I'm going to divide each term by 4 here. So that means that my final equation is going to look like x minus 4 squared plus y plus 8 squared over 4 equals 1. And it might be a little easier to see our numbers if we put a 1 under this one. The center of our ellipse is going to be 4 comma negative 8, and the two radiuses are going to be 2 and 1. And I'm going to stop there, partly because I'm out of battery and partly because it's the same process as the last one. This one is a short, a skinny but tall ellipse. All right, take care. Bye. I forgot to cite my sources, so here are my sources for today. I used some equations, I used a GIF, and I have my template. Okay, thanks, bye.